Welcome to PIC Computing, A-Level Computing video number 24. This video comes in two parts. We're looking at negative binary, and in the first part we're looking at sign and magnitude negative binary. Now, we saw in the last video when we were subtracting binary that if your bottom binary number is bigger than your top binary number, just like in decimal, we might end up with a negative value. Now, the answer there, minus 100, we can display nicely on the screen here, but for a computer to be able to interpret that, it wouldn't be able to do it because it can only understand ones or zeros. It can't understand minus signs. So we need ways of representing negative numbers in binary for a computer to understand, and there are two methods. The first is sign and magnitude representation, and that's the easier of the two methods, and we'll look at that in this part of the video, and in the next part we'll look at the harder way of doing it, which is called 2's complement. So, sign and magnitude representation. With this representation, the first bit in the binary number that we're looking at represents either a plus or a minus. If it was 0, it would represent a plus, and if it was 1, it would represent a minus. So if we take our base 2 number system for 8 bits, we know that it goes from 1 and it doubles each time until it gets to 128. If it was 8 bits in sign and magnitude, we wouldn't be able to use the 128. It would disappear and be replaced by a plus and minus column. Then, if we took a binary number, which is 11101010, this equates to 106 in decimal. Now, because we said that the first bit in a sign and magnitude binary value would represent the plus or the minus, if we put a 1 now at the beginning of this binary number, this means that the value is actually minus 106. So basically all of the bits in your binary number, apart from the first one, we convert into decimal as normal, and then the first bit represents either a plus or a minus. So it's 1 there, and we say if it was a 1 it would represent a minus. If we change that now to a 0, we'd be representing a plus 106 again. It doesn't have to be 8 bits that we're dealing with though, so look at another example. We're not going to use the 16, that's going to be replaced by the plus and minus. There's our binary number, but we're only using 4 bits or 5 bits with this example. So we know that 1010 is 10 in decimal. So if we put a 1 in front of it, we've got minus 10. If that was a 0, we've got plus 10. If you're wondering where the name sign and magnitude comes from, we've got to remember that if we drew a line after our first bit in a sign and magnitude representation, then that first bit represents something very different from the other remaining bits. It represents either a plus or a minus, doesn't it? And this is known as the sign, which makes sense because plus and minus are both signs, aren't they? And the rest of it after that is known as the magnitude. So it can be split up into 2 bits, and that's how it gets its name. Where a little bit of confusion might come in surrounding sign and magnitude, where we know that in sign and magnitude this binary value would be equal to minus 10, because 1010 is 10 and the 1 at the front makes it a minus. But of course, if we wrote that down in standard binary, it wouldn't have anything to do with 10, it would actually come out at 26. So that begs two questions. Firstly, how would a computer know what it's looking at? How would it know if it's looking at standard representation or sign and magnitude representation? Well, you won't need to know the answer to that for the exam. That might be something you can try and find out through your own research. The other question you've got to ask yourself is, and this is more important, how do I know what I'm looking at in an exam, whether it's standard or it's sign and magnitude? Well, you'll be told. For example, here is an example question from a past paper. So we've got a binary number there, but it tells us it's in sign and magnitude form, and it's asking us to state its denary value. So if you're wondering whether it's standard representation or sine and magnitude, you will be told if it is sine and magnitude form. Hopefully you had a go at that last question. If not, just skip back, pause the video and see if you can calculate the answer to it. What other things are you also going to need to know about sine and magnitude for an exam? Well, you might get asked about advantages and disadvantages to this sort of representation of binary numbers in negative. Well, one advantage to it is it's quite easy, as you've seen, but there are more disadvantages. One is that with 8 bits we could only represent 127 or minus 127 instead of a higher value of 255. With 4 bits we could only represent 7 or minus 7 instead of 15. And a good thing to remember also is that it's difficult or almost impossible to do arithmetic with sine and magnitude representation. For example, how do we add a negative 5, which is 1101, in sine magnitude to anything represented in standard binary? The two just don't mix. So pause the video, have a look at this example question from an exam, which is worth a lot more marks than the previous one we looked at. And that might explain to you why it's good to know about the advantages and disadvantages of sine and magnitude too. In the next video we shall look at the other way of representing negative binary, which is called 2's complement. Thanks for watching.